Go.
Hey everybody, welcome back. So we just covered that at the end of the day, computers really only understand one language, ones and zeros, or ons and offs. So the only way that they can represent state or maintain any information is by encoding it like that, which kind of makes sense if there's only one computer. But what happens if there's more than one computer, Corey?
Right. So communication between computers is actually just as simple as that, right? We need a way of sending that 1 and 0 representation that represents the data in that machine to some other machine. So we can imagine just putting a wire between two machines. Think back to when everything was wired and connected. That's what we're talking about here. We have one wire between two machines. Now this wire needs to be able to send these ones and zeros between another machine. Well, how can it do that? Imagine a light switch that I could turn on and off really, really, really fast. Okay. Imagine I said to you, I want to communicate to you in ones and zeros with a light switch. We can say every 1 second, Matt, I'm sending you an information. And whatever the light state is at the end of that 1 second is the information that I'm sending. So I can turn a light switch on and you can go, okay, it's on. After that next second, I might turn it off. And then you might go, oh, okay, that's a 0, right? And then I might turn it back on, that's a 1. And then I leave it on, and it's another 1. And then I leave it on, and it's another 1, right? And it's I can represent these ones and zeros over a single wire pretty quickly. And if I can move that light switch on and off, throughput really fast. That's how we can send this data between two machines. It's as simple as that, right? Sending ones and zeros across this wire really, really, really fast. In fact, that's the basis of where you hear about Ethernet cables and fiber optic cables, right? Ethernet cables are based off of electrical impulses. This electrical signals being turned on or turned off really, really, really fast. Ethernet, right? Or fiber optic. This light switch is being turned on really fast, right? Or turned off really fast. And so we're able to communicate those ones and zeros in a really natural way, the way that computers can understand. We call this Ethernet connection or data link layer connections.
Okay,
Yeah.
That makes sense. But what happens if there's a lot more computers, more than just one or two talking to each other?
Right. So if we don't plug them directly into each other, this becomes a problem, right? Because if you think about the fact that, it's not just me and you here, we got Lily right out there teaching a class, right? It's a more complicated scenario when we're all around trying to communicate either between two computers or three computers or four computers. Often we have this super small special computer called a switch. And the entire job of a switch is to basically relay information to other people on the same local network. But how do we know who to communicate to? With two machines, it was really easy. I just plugged my machine in and plugged your machine in, and they were able to talk. But now with multiple machines, we need another way. Well, how would you know if I was trying to talk to you or Lily? I would say your name. Right? Okay. Yeah. So what computers tend to have is their own name. And the name that computers have is a MAC address. That's the idea. Now my Mac, right? My MAC address, okay? And so the MAC address is built into every single piece of hardware that is able to communicate, right? And it is a formal name that the computers use, and they go, hey, Corey's computer would like to talk to Matt's computer. And this special piece of hardware in the middle called the switch will go ahead and actually relay that information for us. It's pretty cool.
Okay. I mean, that sounds great if I'm going to have a LAN party, but what if I want to talk to people in Europe or far away from me?
Right.
Like, I don't have a cable reaching all the way to Europe, do I?
Right. Well, the funny thing is you don't know about it, but you do. And so you don't have a physical cable right in front of you, but somehow you need to be able to communicate to Europe, to Asia, to somewhere far away. And the problem becomes increasingly more complex, right? Just as when we had a very small short story of just two computers connected, the problem was a lot easier, right? But now with a lot of computers, we have to scale up. We have to think about this. We call this the OSI model, right? How do we start to communicate at higher and higher and further scales over more complex connections? The story changes whether you're trying to contact an email server out in Europe or whether you're trying to contact a web page that you might find out in Europe, right? So, and the way that you communicate might be same in terms of ones and zeros, right? We always have to send ones and zeros, but the story changes. The kind of information that we'd want to send changes. And this is the complex problem that we're going to talk about through this networking unit. We're going to talk about some of the challenges that we have as we want to scale up.
All right. Pretty excited then.
All right. Well, we'll see you all in the next video.
Take care.